panelists and participants. Bharti Vidyapeeth's Institute of Computer Applications and Management BVI CAM, in association with Computational Intelligence Society CIS chapter of IEEE Delhi section, Computer Society CS chapter of IEEE Delhi section, Technology and Engineering Management Society TEMS chapter of IEEE Delhi section, System Man and Cybernetics SMC Society chapter of IEEE Delhi section, Communication Society of IEEE Delhi section, Consultants Network Affinity CNA Group of IEEE Delhi section, Life Member Affinity LMA Group of IEEE Delhi section, Inter-Society Relations IRS Standing Committee of IEEE Delhi section, Industry Relation and Special Interest Group on Humanitarian Technology, Site Standing Committee of IEEE Delhi section, Region 10 of IEEE with the Associations of Computer Society of India, CSI, Institute of Information Technology Professionals, IITP, ISTE Delhi section, and IETE Delhi Center as technical collaborator welcomes you all to the IEEE IETE BVI CAM technical lecture series on sustainable IT. Sustainable IT, also known as green IT, covers the manufacturing, use, management, and disposal of information technology in a way that minimizes its impact on the environment. Global warming is no longer just a scientific concern. It's a collective responsibility that requires action at every level, starting from individuals. Each of us can make small yet impactful changes like conserving energy, reducing electronic waste, or embracing sustainable habits that contribute towards a healthier planet. However, as IT professionals and engineers, we hold an even greater potential to make a difference. The IT industry, with its vast data centers, energy hungry cloud infrastructures, and expansive digital ecosystem, has a significant environmental footprint. In this lecture today, we'll explore how the principles of sustainability can be woven into the fabric of information technology while examining the environmental impact of IT operations and uncovering strategies for designing energy efficient cloud architectures and learning how infrastructure as code, DevOps, and CI CD pipelines can be adapted for sustainable practices. Additionally, we shall also dive into green coding, the role of microservices in sustainability, and how optimizing algorithms can reduce resource consumption. By embracing these practices, we can not only reduce the environmental footprint of our IT solutions, but also lead the way in building a more sustainable future for the tech industry and the world at large. I would first take this opportunity to welcome amongst us our distinguished panelists for the day. We are privileged to have amongst us a galaxy of experts. I would first request Professor Emin Huda Sir, Director, Bharti Vidyapeeth's Institute of Computer Applications and Management BVI CAM, and Chairperson IEEE Delhi section to address the participants with his inspiring words. Over to you, sir.
Am I audible?
Yes, sir.
Good evening, one and all. And at the outset, let me welcome today's valued speaker, Mr. Swaradip Chaudhary, the principal engineer from Nagaro, to have discussion and make us to know that how and in which way the IT applications in general and computing in particular can be utilized for the purpose of sustainable development. Because multiple developments have come, but are we compromising with the resource utilization, or otherwise if we are doing, how we can explore for having a better and optimized system. Thank you so much, Mr. Swaradip, for having accepted our invitation and being with all of us to share your experience, share your knowledge with all of us. Thank you so much. I also take this opportunity to welcome and pay my gratitude to all the panelists as well as very, very senior people amongst the attendees who from all parts of the country have joined and have been joining since beginning. Dear friends, all of you know that this program was started, this evening webinar series was started at Saturday evening, IEEE IETE BVI camp evening weekly webinar series in a backdrop of COVID-19 in May 2020, and 4.5 years have already been passed. And last year when IEEE was adjudicating this, they realized that this is one such sustainable series. Our webinar itself is such sustainable series that we have won from all over world. This was adjudicated as the one of the best sustainable knowledge dissemination program being run continuously with 100% sustainability, and as having been started at the backdrop of the COVID-19 when entire world was blank what to do. So this is a great achievement being sustainable webinar series since last 4.5 years. It's not easy. And we have been adjudicated as the best and we have got award certificate for that. So this credit goes to all my team and all the participants from various parts of the country and abroad, and my speakers who made me to keep it as a reality. Thank you so much. Dear friends, sustainability, as Dr. Ritika has already briefed you, primarily sustainable, when we are talking of sustainable development or sustainability, is primarily an approach to growth and human development, utilizing the technology, but keeping an aim that whatever we are doing, that meets the need of the present without compromising the ability of the future generations to meet their own need. आने वाली generation, the future generation should not tell us and should not realize that my prior generation have utilized all resources and there is nothing left, or very the resources are left in a very scarce manner. So the aim is that the society where living conditions and resources meet human needs without undermining the planetary integrity. When I'm talking this, there could be multiple dimensions of the sustainability, but there are four important dimensions: economic sustainability, environmental sustainability, social sustainability, and cultural sustainability. When we are utilizing IT, the most important benefit which we get is economic benefit. But the kind of the, if we are not utilizing in an optimized way, the environmental sustainability, because of carbon footprints and because of multiple electronic resources being used in the process, may become a challenge. So today's discussion is primarily to have that discussion threadbare and make us to understand that many of us are utilizing IT in a big way and all of us are utilizing in one or other way. So how and in which way we should be careful about it. Thank you so much. There are other webinars which have already been announced. So if you have not registered by now, please register for that and keep attending those webinars, because when you attend those webinars, this gives us encouragement, motivation, and we schedule such webinars in a very regular manner. Believe me, scheduling a knowledge dissemination session and having a speaker from industry, top-notch speakers from industry, is not an easy task. Dear friends, one more request, that the recording of all these webinar sessions are available at our YouTube channel. So those who miss any of the part, or if you have missed any of our prior webinar, please go to the YouTube recording, the huge repository. 164 such webinar episodes have already been done. Today is 165th. So all these recordings are available. Utilize those recordings and drive maximum benefit. Thank you so much. God bless you all. Wish you all the best. Keep learning despite disruptions. Over to you, Dr. Ritika.
Thank you, sir. With this, I would now welcome amongst us our expert speaker, Mr. Sauradipta Chaudhary, with a bouquet. Welcome to the session, sir. Mr. Sauradipta Chaudhary is an alumnus of NIT Jalandhar. With over 2 decades of extensive experience in the IT industry, Sir has previously worked with Cognizant. Currently, he's serving as principal engineer at Nagarro, a global leader in digital engineering. Sauradipta has a proven track record of designing and implementing cutting edge cloud native solutions for diverse clients across the globe. He is passionate about delivering end to end solutions from conceptual design to seamless implementation and thrives on addressing complex challenges with innovative and effective approaches. We are honored to have you among, sir, and I would now request you to kindly enlighten the house. Over to you, sir.
Now shall I share my content and
Yes, sir.
start?
Yes, sir.
So it's in today's world, it's almost undeniable that whatever tasks we do, be it in our work life or be it in our professional life, it leaves an impact on the environment, right? From the way we eat to the way we travel, everything leaves a carbon footprint on this world, right? Technology is driving almost everything today, be it innovation in the industries or be it the way we are personally interacting with our friends through social media like WhatsApp, Facebook. Everything has technology in its roots. And that is why it is very important to understand how this technical ecosystem is impacting the global environment, not just in a negative way, but also what are the possibilities that this technology provides us with so that we can use the power of technology to kind of bring a positive impact in the environment, how to keep the environment more and more sustainable. So we will have to look at both sides of it. And while we look at the positive sides, in today's session, we will look at the industry initiatives by the leaders of the world that are being taken, the green software patterns, how as developers and architects and designers, we can come up with so-called green applications, which are better for the future. Green ops is a terminology which I would introduce. And then what is the concept of digital citizens as such, and what's the way forward from here? So before we understand the overall global impact of IT, let's take a quick look at what are the constituents of the IT ecosystem, right? What is IT made up of, right? So IT obviously has a lot of hardware, right? The end user devices like the computers, the laptops, mobiles, gadgets, everything, the servers on which the applications are running, the various IoT devices today, right? We have different receivers implanted across our environment, which collects a lot of data, transmits a lot of data. And obviously the networking equipments like the switches, the routers, which are keeping all of these hardware connected. Then we have the software solutions, like the apps that are being built, we use on our mobile phones, the websites that are running, the data pipelines that are moving data from one point to the other almost every hour these days. And then the media content, the video files, the photographs, the images, and the documents. Then we have the people. So across this entire IT industry, we have people with different skill sets that make this industry run. Like we have the architects who are coming up with the designs for these hardware and software solutions. We have developers who are implementing those designs to come up with the products in the end. Then we have the manufacturing workforce who are working in the factories, in the assembly lines that are manufacturing those hardware equipments. We have testers who eventually test that the applications that have been built are they compliant with the requirements that were provided by the business. We have product owners in the first place, like they capture the requirements from the business, like what should be the nature of the application, etc. And obviously, in the end, we have the end users who are consuming these solutions day in, day out for different purposes in their life. Everything is almost automated today. Whatever we do, most of it is digital, right? And binding all of these together is obviously energy, because everything in this picture that you see, it would need power, electric power to run, some sort of power to run, and majority of it is electricity, right? So this is what the IT ecosystem is made up of. And if we look at a higher level, at an aggregated level, then we need to take a pause and look at the bigger picture. That was the IT ecosystem, but then what's the bigger picture that's known to all, right? So the hardware that I was talking about that are generally used in the IT devices, right? So they need steel, aluminum, plastic, silicon, rare earth metals, gold, and copper to be built, right? So they are very, very, very delicate and rarely available elements that are required for building these semiconductor chips, etc. Less than 1% of copper and rare earth metals comes from the raw ore. Now just imagine, for the extent of hardware devices that we have prepared, the amount of raw ore extraction that would be required to generate that amount of copper, right? And ore extraction is a process which needs massive water usage. Now we are running short of water globally, and on top of it, if we keep on extracting more and more ore, then we are using water even more. We are depleting our natural resources. Then the metal extraction and the purification process, we just can't use the raw metal as is. First, after the extraction has a process in it, then we need to purify it. All of it needs very high amount of energy, and the majority of that energy that we are using to run these processes, they are coming from fossil fuels, which are non-renewable source of energies, and that's a very, very big threat as of now, right? Now, if you look at this picture on the left bottom corner, right, I just went into ChatGPT and I asked it, give me an image which showcases the magnitude of the problem of e-waste that we have today. And imagine ChatGPT has given me this picture, the one which you see here at the bottom right corner. And ChatGPT is basically, as we all of us know, it's an AI model which kind of is a representation of the knowledge that is available spread across the internet, right? And this is what it looks like. E-waste is this big a problem. 62 million metric tons of e-waste is generated globally as per the records collected till 2022, and that was an 82% jump since 2010. Just imagine the rate of increase of e-waste. Only 22.3% of e-waste is formally recycled. Rest of it ends up in landfills. It's polluting our environment. We are only capable of processing 22% of it. Now, this entire e-waste problem, it's projected to reach 82 million metric tons by 2030 if something is not done immediately. And if nothing is done, obviously, these numbers, they look very scary, right? Now, talking about the software and the people factors, we just looked at the hardware factors. And what about the software, right? So software meaning in Google Play Store, if you look today, you would get to know that there are around 2.4 million apps available to download in Google Play Store. Similarly, in the Apple App Store, there are 1.83 million apps available. There are over 1.1 billion websites that exist on the internet as of September 2024. And these are only the numbers of the applications which have been tried and tested, are successfully consumed by the end users. Behind every successful application that is rolled out, there might be 10 to 15 failed applications. So just imagine the amount of coding that the IT professionals are doing these days, right? You can look at the numbers here. It's 55.3 million IT professionals worldwide as of counted in 2020. And all these professionals, they are using some device or the other to write their code, to execute their code, to test their code, and every activity that is required to develop. And using those devices at the end of the day, as we all understand, needs power, right? So again, so 55.3 million IT professionals using these many devices, building these many apps, we are consuming energy. And most of that energy, again, as I said, comes from fossil fuels. Like 80% of the global electricity that is required to run the IT infrastructure and to consume the gadgets, the IT gadgets, 80% of that electricity comes from fossil fuels, which means very little amount of energy is being sourced from the renewable sources of energy. And that's a problem. 1.15 trillion semiconductor units were shipped globally in 2021, powering a vast area of electronic devices. All these mobile phones, they keep on coming every year, new models we keep on purchasing. It needs semiconductor, like I showed in the previous slide, and semiconductors are made out of very rare metals. And it's a very expensive process, and it's very hard on the environment to get those raw materials which are required for these semiconductors to be manufactured. Now, if you look at the last metric that I have, so like operating the IT devices, they contribute to around 2 to 3% of global CO2 emissions, which is almost comparable to the airline industry. Airline is said to be one of the, one of those industries which is impacting the environment very heavily, and IT industry is not falling very far behind that industry. If we look at these numbers, like I said, they look very scary. But then you look at the hyperscale data centers now. We take it a notch higher. See, now everybody is talking about cloud, right? And it kind of gives us the impression that, oh, it's just a laptop that I need to run my compute engines, etc. But that's not the reality. So cloud operators are doing nothing. So they actually have this vast array of physical infrastructure built in their backyard, and they are just letting us use it on a shared model basis or a pay-as-you-go model. And it gives us an impression that we are using just a laptop to use those things, but that's not the fact. There is a vast array of servers that are being deployed at their data centers, right? And the major players in the cloud are the likes of Amazon, Google, Microsoft. The data centers they have built, they are mammoth in size. They are called as the hyperscale centers. And each of those centers are very high tech, and they kind of house more than 5,000 servers with extensive network connectivity and heat dissipation unit. Just imagine 5,000 servers in a warehouse kind of a building, continuously running, the amount of heat that it would generate, and the amount of mechanism and the heavy lifting that would be required to dissipate that heat safely to somewhere else. So that's the scale of cloud that we talk about, right? There are around 7,500 data centers globally of multiple sizes, out of which there are roughly 600 hyperscale data centers, the ones which are as big as warehouses which house more than 5,000 servers, and 40% of it is concentrated in US. 6% of the total electricity demand in the US goes to the hyperscale data centers. 130 million cubic metrics of water used for cooling the data centers in US. Like I said, you can very well imagine if 5,000 servers or 6,000 servers are operating continuously, it would generate heat. Even if you turn on a 17-inch monitor close to you on your tabletop, you would feel that heat somewhere on your face. Now imagine increase it to that count of 5,000 servers operating. You can very well imagine the amount of heat that is getting generated and is eventually being dissipated into the environment, right? They need to be cooled, and water is used extensively for that cooling mechanism. Out of those 55.3 million IT professionals right now, many of them are employed in these hyperscale data centers. You look at this graph here, you could see how steeply the number of data centers have grown over a period of 10 years or so, right? So there was an internet boom in 2000, and then there was the digitization boom, due to which the need for more and more data centers has been ever increasing, and it has now kind of plateaued in the sense, yes, these centers, they did their optimizations to keep themselves small, to improve their efficiency. But with the new giants coming in, like the AIs of the world, which needs more and more processing power, their optimization techniques, whatever they had used in the data centers, have plateaued, and now they need to come up with more and more centers, which means this number is going to increase in the coming years. Very thoughtful, very scary. But then, do we stop growing? Does all these numbers tell us to stop growing? I would say no. What we need to do is we need to make this growth sustainable. Yes, we need to grow. Otherwise, there is no point for human being to live. But this growth has to be sustainable, right? And how do we achieve that? Like I said, so the big players, the Amazons, the Googles of the world, the Microsofts, they have taken a pledge in collaboration with the government agencies and other organizations. They are collaborating, and they have taken a pledge, and they have set internal goals for them, right? What are those goals? Like Google and Microsoft, they are pursuing net zero emissions across operations and value chain by 2030. Goal to operate data centers and offices on 24/7 carbon-free energy such as solar and wind, meaning they are targeting to meet all their energy demands for not only their data centers, but also the offices from where they operate. The net energy demand of these companies, they have a target of drawing that from renewable sources of energy like solar and wind. You can look at this picture here. You would see solar panels getting laid down. This is an image from one of the Google data centers in Frederica, Denmark. So there are regions which are actively working towards making renewable energy more and in a more sustainable way. So yes, so the target is that. So they are pairing up with federal agencies, with government agencies to come up with solutions like this. They're acquiring land close to places where renewable energy is in abundance, so that the data centers they would build, they will not have to take that energy from the regular electric grid, but they would build renewable energy grids for their data centers, and they will meet 100% of their energy demands that way. On the other side, AWS, that is Amazon Web Services, the biggest cloud player, they have brought in design innovations within their data centers. The way they have built the data centers in an innovative way and how they operate it, they are able to provide 12% more compute power. They're becoming more and more efficient in terms of computation capabilities, and while at the same time they're also improving their power usage efficiency rating. Now, by power usage efficiency, we mean with less power, they are able to operate more and more devices, thereby giving the scalability aspects. There is a short video that I would like all of you to listen to. This talks about the circular model that they are following in the Amazon data centers. And this, but through applying this model, they have been able to make their data centers more and more sustainable. Just have a look at this video. I'll just play it. Let me know if the sound is not audible.
AWS is building a more sustainable business because that is what our customers want. And one of the ways we are driving sustainability at our data centers is by expanding our circular economy efforts. I'm Manju Murugesan, and I work on the sustainability team here at AWS. Our strategy for accelerating our transition towards circularity is based on 3 pillars: design better, operate longer, and recover more. By designing better, we unlock more potential than at any other stage of circularity. We design to avoid waste by eliminating excess materials, enabling more reuse and recycling, and using materials that are safer for people and the environment. Next, we plan to operate longer through robust maintenance of data center hardware to avoid early retirement. At AWS, we consolidate individual functional hard drives from multiple aging racks into fewer, fully functional racks, extending the lifespan of S3 hard drives by up to 2 years. By sending only broken drives for recycling and avoiding the early retirement of healthy working drives on the same rack, we increase water and energy efficiency. Finally, we aim to recover more. Through repair and reuse of used equipment, we avoid the carbon and costs associated with the purchase and manufacture of new components and materials. AWS sends securely decommissioned equipment to our regional reverse logistics hubs to assess, repair, and recirculate functional equipment back into inventory or to be sold for reuse by third parties. By designing better, operating longer, and recovering more, we will continue to expand on our circular economy efforts. Our acceleration towards circularity means we use today's equipment to build tomorrow's, charting a path for AWS, our customers, and the global supply chain to reach new levels of resource efficiency and to build a more resilient future for the planet.
So if you have been able to listen to this video well, then you would see that the principles of making a sustainable data center are pretty simple, right? See, first, what they said was we need to design better. by designing better means they need to have a proper, they need to select the right kind of materials, the right kind of layout for placing their servers, etc., such that the energy requirement is less. A simple example, if you have a very long wire connecting to your device compared to a short wire, then the amount of time that the electricity would have to travel would decide the amount of heat dissipation, right? But if you can optimize the length of the wiring in your data center as well, then some way you can save on that kind of heat generation, right? So that was about design better. That's one aspect. And then use advanced materials which are efficient in themselves, which do not, which have the ability to, with very little amount of material, its ability to perform more. So those kind of materials, and that's where research comes into play. That's where the academic brain power also comes into play, because there are different researches going on across multiple universities across the globe to come up with these kind of materials, to come up with these kind of chemicals which can help us achieve these goals. So that was the design aspect, design better aspect of it. Then the second parameter or the second aspect was operate longer. Build systems so well and maintain them so well that you increase the life expectancy of that server or that device. Now, how does that help? See, because if you have a short-lived device, let's say your device needs an upgrade every year, that means every year you will have to dispose the old device and buy a new one. Like compare it with a mobile phone, right? So your mobile phone, you start saying it's getting slow because of OS, because of this, because of that. Eventually you end up throwing it away or reselling it and then buying a new phone, right? But had you maintained your phone well, maybe that could have run a year longer or 2 years longer, right? Now that if the rate of upgradation increases, that means you are adding to the problem of e-waste, like we saw in the initial slide. More and more devices you throw away, you are adding to the problem of e-waste. That's why if you can increase the life of your devices, in a way, you are making a sustainable move. That's point 2. The third one was about reusability, right? Or refurbishment. Let's say you have given up an old device. It was, yes, you did your expectancy had increased, but eventually it will wear down and you'll have to throw it away. Instead of dumping it, you send it to refurbishment centers or repairing centers. You do minor tweaks, right? And then again you resell it at a lower cost or reuse it at a lower cost. That way, obviously you are saving costs, operational costs at your end, but at the other end, you're doing a great, that's a great thing for the e-waste problem. That means that device does not end up in the e-waste junk or anywhere, but it's again getting utilized. So in a way, that's a problem of optimizing your devices so that you don't end up buying or producing more and more hardware, right? Eventually you will have to, but then you're just delaying the process. You're just delaying the problem, right? So that was all about that AWS circular model, which they're following in their data centers.
AWS is built.
Yeah. Next, another innovation that Microsoft has brought in, I think the other data centers are also looking at it. So they are now using liquid immersion cooling at Microsoft. I told that, for data centers, they generate a lot of heat and they need immense amount of water to cool themselves down. The servers need to be cooled down to maintain their performance levels, etc. Instead of water, they are using some different kind of a liquid, which they call it as the low boil dielectric fluid. Now, that is a kind of fluid which enables recapturing and reuse of the heat. So the way it is, when you use that fluid to kind of cool down the thermal energy that is getting generated, the thermal energy gets converted into vapor easily. You can capture that vapor because the vapor is at lower temperatures, because it has it's a low boil liquid. You can capture that vapor and then you can use it to run some other applications. Instead of just sending it out in the environment that way, you're reusing that thermal heat generated from the servers for some other purpose, right? And this entire thing also allows them to stack more processors in lesser racks. So which means now I have the ability to cool down. Now my cooling power has been enhanced, which means I can generate more and more heat within this within a small space. I can still cool them down. That means the size of the data centers are getting reduced, and with a reduced size, you would eventually need lesser power to run. So that's a two-way benefit that they are getting using the low boil dielectric fluid, and they claim that they are close to 98% energy efficient already. Mind you, they had a target of becoming net zero target of achieving net zero climate goals by 2030. So their energy consumption by using this approach, that has dropped by 15%. The overall usage of water has reduced drastically. So in the regions where these data centers are built, so the water crisis problems that were showing up, they have been greatly reduced. Now, there's another aspect called as the carbon offset. Now, what is a carbon offset? Carbon offset is, yes, I have at some point in time, I have to agree that I cannot stop producing carbon footprint all the way, right? If I have to work, if my machines have to run, some amount of carbon will be generated. I cannot, control that. Something will be generated, maybe less, but still something will be generated. I cannot stop that. But if I do something on the periphery, like in some other area, I do a compensating act, right? I do some sort of compensating and in a completely unrelated field, such that the carbon that I'm adding here, I'm saving that carbon from the other side, so that the overall balance of the environment stays intact. So that's called as carbon offset. And one of the initiatives that Google took was that they have a data center in Hamina, Finland, and they have reused their energy. There's another short YouTube video. So I wanted to show you these videos because I could have portrayed the information verbally myself, but then if you hear it from the people who have done it, the emotion gets translated. I believe you will understand better, right? So just hold on, I'll just play this video, short video. Just look at this initiative.
At Ekami, we have done what we can to minimize our carbon footprint. We have installed solar panels and reduced our energy consumption. Heating, however, is still a burning question for us.
When we started back in 2011, the challenge was to cool down the servers. But then we found a creative solution. Seawater, just pump it in from the bay. And then we have our heat recovery initiative. Data center creates a significant amount of heat as a byproduct. At Hamina, we have been recovering it for almost a decade now. But then we want to do more.
We've long wanted to channel our recovered heat off-site and to be used by the local communities. After years of extensive work, we are finally able to put our dream into reality right here in Hamina. Finding the right off-taker is crucial. That's why we're delighted to partner with Hamina Energia to share our recovered heat to the local heating network.
Back in 2006, Hamina Energy made the first investment for the wind power production. In 2018, we developed further when we invested for this particular district heating factory. We were able to cut down the emissions, and then also we were able to cut down some pricing for our customers as well. This new cooperation with Google would ensure even more affordable and sustainable heat for the customers in Hamina Energy district heating network.
For Rekami, education and sustainability go hand in hand. They help future generations thrive. Google's bold work in Hamina doesn't just warm our bodies, but our hearts as well.
Hamina is only the start. Heat recovery is a major opportunity for energy conservation and transition, and Google is working to make it a reality in our data centers worldwide.
Pretty awesome, isn't it? So this was one of the first ever initiatives wherein if you think about it, data centers are constantly generating thermal energy, and they have redirected the thermal energy to the heating grid. Heating grid means in the cold countries, there's a huge need for heating, keeping their houses warm, right? So if data centers are a source of thermal energy, then why can't that be used to heat up to use their thermal energy to heat the houses in the neighborhood? So quite an innovative idea, and it's exactly innovations like these which would be required to keep the cloud sustainable, to keep this IT sustainable. It needs investment. They are investing. So the money that they are charging from their consumers, a part of it, they're heavily investing to meet their overall goal of, the overall climatic goals that they have set. So moving out from the cloud leaders, etc. Now let's look at, what, people like us, the architects, the developers, the people component that we were talking about, what can they do to build something called as a green application, or what we call as green coding, right? So there's this organization, Green Software Foundation. It's a free source, open source organization which have come up with principles, and it is just one of them. Okay, there are other organizations which are doing it also. Within Nagarro also we are doing it. So we are coming up with green principles, right? So the green principles meaning, so if I have to design a data pipeline, this is a kind of solution that you need to do. This is a sustainable solution. There are certain principles and there are certain software patterns, right? We have been talking about, coding patterns, design patterns, solid principles. Those were all related to building well-structured code, well-performing code. Now we are talking about patterns by following which we can eventually end up building green solutions, green applications. And then these patterns, they'll have to be used on top of the various kind of services that the cloud providers provide, or in for that matter, the on-prem solutions are there, right? So basically the concept is we now need to take sustainability seriously in the application designing and in the application development space. We need to come up with tried and tested software design patterns and developing principles, and make the architects and the designers follow that as a guidebook, and give them the assurance that if you follow these principles, these patterns, okay, eventually you will end up building a green application. Now, what is the nature of these patterns, and what are the kind of activities that I'm talking about, right? I'll quickly take you through that. So something called as the sustainable design principles. So when as an architect, I'm thinking of a solution, to a technical solution to a problem, it's advisable that I adopt shared resource models for hosting your applications, right? What do I mean by that? I can easily spawn up a server. Okay, I can host my application there. The server can maybe do X hours of computation, but my service only needs, let's say, 10 or 12 computation cycles in an hour or so, right? Which means majority of my server compute environment is going to waste, right? Instead of doing that, we can approach a serverless approach. So these cloud players, Amazon, Google, Microsoft, all of them have now serverless offerings, which is nothing but a sharing basis, right? So they have a server, they have a service which is running, and along with me, there are 5 other customers who have the same kind of a workload to deploy there, right? Instead of giving a dedicated environment to all, there we can deploy, they're doing a logical separation there, and all of the applications are running on a single server. And that server is getting optimized. The usage of that server is getting optimized. That way, you are using less hardware, right? Number of hardwares that need to be operated are getting reduced. And obviously, that gives you the energy saving. Then the other aspect is microservices, right? So let's say if you have a very large application which has multiple modules in it, right? Instead of keeping all of it in a single code base, a single application having multiple modules, you need to deploy it everywhere as a single unit. Instead of that, the principle says break them down into, break each module, convert each module into separate applications and then get those applications interconnected, right? So which means instead of having one large big monolith application, right, which is very huge, you have small applications, right? And smaller applications are easier to operate, easier to run, and you can decide whether to give more server power to application A or application B or application C. That way you can optimize the usage of the servers. So that's the usual concept of microservices, where the concept of auto scaling, etc. kick in. Next is the apply just-in-time computing principles to avoid empty processing cycles, event-driven design, right? I can go to a post office every day and check whether I've received a letter or not, okay? Or I can have a postman ring a calling bell. I mean, that's a very old example. I'm not sure if that makes sense, but let's say notification based, right? I can open my app every time and see if I have received an email, or I can wait for a notification on my mobile phone. And only if a notification has arrived, only then I would go to the app, open the app and read that email. In the previous approach, wherein I was opening the app every time, I'm unnecessarily using that application. Even if I have received mail once a day, I might have opened the app 30 times a day. Wastage of 29 app open cycles, right? Instead of that, if I have a notifications driven kind of a strategy in my mind, I would have opened that app for that day only once. That's a saving, event driven design, right? Then we reuse the pre-computed data, right? If we need to do some sort of data crunching, calculations, etc., if that data is not going to change over a, let's say, a longer period of time, it makes sense if we compute the data and save it somewhere so that the next time we need it, we do not run that heavy computation again. We just bring that data wherever it was saved and use it. That way you are reducing the computation cycles. And then keep large static data close to the end user to reduce the network hops, something what Netflix does, right? So you are sitting in India, your videos are getting served to your mobile phone through a server which is close to the Indian location. Your data is not coming from USA servers. Your data, your media is coming from the India server. That way, what happens? The amount of network hops that media file has to do before it reaches your device would be lesser. And if a media file needs to travel for a lesser amount of time, obviously the energy consumption over that networking circuit would be less. So these are certain design principles which, if you can blindly follow in your application design, you would end up building a sustainable application for sure. That was the architectural side of it. Let's look at the coding principles. The developers, what can they do? Eco-friendly UI design, right? So low resolution images. I mean, it's not important to give a very high resolution image of a graph or an icon or a chart or anything. The more amount of pixels you bring into your image, it's more amount of heat that is going to get generated out of the display unit. So use low resolution images as much as possible. Darker themes, build your applications with darker themes, because darker themes emit less energy. lazy loading. That's a concept which says do not load the data to a device that is not required by the user. You should have design principles, you should have techniques within your coding so that you load only that amount of data onto the device that is required by the user. If you load extra data, the energy required to load that data, to make that data available to the device, is a waste. So follow a lazy loading principle. Choose algorithms which take smaller space and time complexity. Right? If you have a problem statement, let's say you have to do a sorting, right? There are multiple types of sorting algorithms which are favorable to different type of situations, right? So when you select an algorithm, look at the amount of space amount of space that it would take in the in-memory operations, right, during the algorithm works, and the amount of time that this algorithm would take in order to get that problem solved. Do not select blindly the first algorithm that comes to your mind. Assess multiple algorithms and check the one which has a smaller space and time complexity. Something like you need to see if you can reduce the number of loops that you are running in your code, the number of database calls that you are making. Can you reduce those number of database calls? Because every time you have to do a database call, you need to do a network hop, your database server gets activated. Instead of calling it 10 times, is it possible to call it one time and get all the data and keep it through caching as a pre-computed data, right? Use efficient data structures, right? So that we have heard about linked lists, we have heard about heaps, stacks, etc. So trees and hash tables, I mean, somebody is coming from a coding background would understand, if trees and hash tables, they are more efficient than linked lists when it comes to sustainability aspects. Again, use leaner OS and packages, and use smaller functions. Do not, I mean, when you write the lines of code, every line of code that you are writing occupies a space, right? And the more and more space you occupy, you're eventually going to run out of your RAM, or you're going to run out of your hard drive. And then you would need more storage, right? So simplify your problem. Use lean packages. Do not just download packages blindly. For one feature, do not download a package which is offering 100 features. That's a wastage. Look for the most optimum package for your requirement. Download that package, work on it, install it, and keep your solution or keep your code base as small as possible. So these were some of the design and coding principles which we call as the green coding principles. After you have built all the applications, etc., obviously you need to measure, right? So it's very important, especially Europe is very strong in this regard. Their US is also catching up, Asia is also catching up. But if you cannot measure something, you cannot improve it, right? So you have to measure the carbon footprint that your solutions are generating. Let's say I am an organization, I have 500 applications running. I am a customer of Microsoft Azure Cloud. So Microsoft Azure Cloud, and similarly AWS and Google, all of them, they provide you with the emissions app dashboard. They have reporting tools which tells you, okay, this is your organization. You have these many servers running on Microsoft as a part of your organization's subscription. And this is the amount of carbon emissions that you are doing, right? And total usage, etc. So there's an entire, yeah. So this is the amount of carbon consumptions that your devices are generating. This is where most of your servers are, and this is where it's happening. So it gives you a very clean dashboard of where you stand in terms of your carbon footprint. Are you meeting with your goals? If not, if there is a deviation, you get to know through this dashboard, and you kind of do the necessary tweaks in your solution. So this entire part is called green ops, or the green operation. So once your application has been put into production, is running, consumers are using it, then you need to monitor it, the operations of that application, right? So you do bring in automation. So if you see some server is consuming more, if you see that some server is consuming more and more energy, you think about options like, do I need this server to be kept on for the night period? All my do I need to keep my servers on for that night period, or do I need to have some automated kind of automated shutdown mechanisms wherein I can decide that if my server is not getting used for this part of the day, automatically my servers would shut down, and next time in the morning it would automatically spawn up. So all these things, these are kind of automations that we are bringing in to the operations part of our infrastructure that comes under the umbrella of green ops. So it's in itself, it's quite an extensive domain, right? So that was all what has been happening. But then now, what's the way forward for us, right? Now, I found a study or a research that was done by NASSCOM, and they did a survey spanning multiple, IT service providers, and they had a few findings. What they are saying is sustainability is now among the top 10 priorities for CEOs. It's not just the IT CEOs, but the other industry CEOs, the CEOs from the companies in other industry domains. Now that means sustainability is really a big thing for every organization. Like I said, in Europe, the norms are pretty strong, right? So you need to report on your ESG standards. I mean, how are you faring in terms of your sustainability goals? There is a mandatory reporting that is being required, and there are targets set for 230 in Europe, wherein by 230 you need to reach that kind of a level. So sustainability is now the most heated topic, is one of the heated topics in the CEO boardrooms, is what NASSCOM says. And they have identified 15 themes, okay, where the investments would pour in, right? And out of these themes, if you look at it, ESG reporting and analytics is one, then green IT and data center operations is the other, right? So these, and green infrastructure and operation design. So these three are the ones which we were talking about. So reporting and analytics on carbon footprint has immense traction now. So there's and all these things. Then there is green IT and data center operations, right? The focus on green IT. Are my applications green enough, right? Are my data centers? Every data center needs to publish its report on how green they are, how sustainable they are. They also have to publish that Western European region is using this much amount of clean energy in the data centers. North European region is not using that much. So all these kind of segregations and brandings and labeling reports are expected out of these data centers, and they are doing it. And that is why the solutions that these IT service industries would build for these companies, they would also have to use those data metrics, and they will also eventually have to come up and say, my application is this much sustainable, so and so, right? And then and all these things, they give us an opportunity of around, what NASSCOM is saying, 150 to 250 billion dollars of additional enterprise spend is to be directed towards sustainability and enablement technology. Now that's a huge opportunity if we look at it for the IT services industry also, because these organizations, in order to meet their reporting standards, or in order to meet their sustainability standards that are being set by the governments in their regions, they will have to look for technical solutions which can enable them to reach there. So that's a huge opportunity, if I think, from an IT services standpoint. AI, right? So AI is the thing that's happening now, right? Now AI can be both good as well as bad when it comes to sustainability. Now let's look at the challenges that AI possesses, right? So in terms of sustainability. So AI needs power-hungry processors, right? So the basis of AI is tons and tons of data has to be processed, and a decision has to be made based on that amount of data. More the data you give those AI chips, better would be the AI solution, which means we need lots and lots of servers, extensive and heavy servers running in those data centers to meet these AI use cases. That's first challenge. Obviously, we know the problems. Now, these programs, these training programs, right, which we execute, the statistical models that we execute programmatically on this data, we call something called as the large language models, etc. They have very long running periods. It's not a short, it's not a 1 minute execution or something. They run for hours and at times for days, right? So if the running cycle of a hardware device gets increased to such an extent, obviously we all know energy is the major requirement. And again, we by now we already all of us understand that long running periods is directly proportional to the negative impact on environment. Google has already said that AI is one reason for falling short of the company climate goals. If you remember, I said Google has a goal that by 2030 they need to be net zero emissions, but they are saying to meet the demands of the AI workloads, that is becoming a challenge, because AI, as I said, it's power. They are power hungry services. Now AI can generate overconsumption by targeted advertisement. That's another problem. So AI being used as, for advertisements, you are getting very personalized ads on your personal devices, right? And it's making you use those applications even more and more. Let's say you had a plan of switching off your mobile at 8 p.m., but suddenly you saw such a personalized ad on your device. You eventually went into that, and then you ended up spending even 1 or 2 hours more on your device. So indirectly, that's a negative impact. So these are some of the challenges that AI throws onto us when it comes to sustainability. But then what are the positives, right? So AI for good, as we call it, right? So these AI models, or through AI, we can help the data centers to data center efficiency by helping figure out the best distribution of cooling mechanisms. Like I said, if you remember in one of the previous slides, AWS had something called as a better design concept, right? How to place the servers, where to place the servers, where should the power unit be placed, right? That ergonomics of it, right? Where should the cooling unit be placed? So AI can easily help in detecting the inefficiencies of the floor layout, etc., and can also suggest the best possible floor layout in terms of in terms of improving the energy efficiency of the data center. So that AI is capable of. So if we can use AI for that purpose, it will give us benefits. Now, AI powered tools can suggest resource optimization strategies. Like I said, if you are a company which is using 500 servers or these many processors, etc., AI tools, if trained properly, they can tell you these servers as at this time of the day they are being underutilized, and those servers at those time of the day are being overutilized, and this is the balancing act that you can do in order to optimize your resource usage. So those kind of decisions AI can help you with, otherwise which becomes very difficult to detect manually, right? The next thing associated with AI is sustainable AI. Now, how do we do that? So obviously we have chatbots, we have this chat GPTs of the world, the mid journeys, etc., etc. Now, for your own problem, right? So let's say you are a pharma company, right? And you need your sales executives to work with medicines names, right? For that, if you use a very heavy model like a chat GPT LLM or a GPT 3.4 or whatever that they call it now, if you use that, so that's a wastage for you, right? So you would be unnecessarily using a very heavy model to just get information for that medicines that you are using, right? Instead, if you can train a very smaller model, right, which just contains pharma related terminologies, then that model would be very lean. That model would be very less energy intensive, and it can be easily deployed, and the running costs from the energy standpoint of it for that kind of a model would be low. So we need to be sustainable when I am opting for the AI solution for my problem. I need to understand what is the most sustainable AI solution that will suit my purpose, right? That is what sustainable AI is all about. Now, the next concept is about conscious digital consumers, the end users of it, right? So we are building softwares, everything, applications are there, but it is the end users who are using it, right? They also have a very big role to play. Optimize device usage, right? Check the ratings before purchasing. Buy devices which are economically rated good, right? Switch to low resolution content. Unnecessarily do not switch to 4K video or a high definition video if you don't need it, right? Most of the time we don't need it, right? So if we are just we're looking for some information, it's not required for me to switch to a 4K mode and look at that video. I can switch to a lower resolution content and I can still get my information. Shut down when not in use. You're not using your laptops, please switch it off. Otherwise, you're unnecessarily wasting energy. Use Wi-Fi instead of mobile data. I mean, if you are at your home or if you're in your office, there's some Wi-Fi connectivity available. Wi-Fi's are less energy intensive compared to mobile data. Mobile data runs out your battery more compared to Wi-Fi, and then your battery needs to be charged. Your devices also gets heated up more with mobile data. So use Wi-Fi data instead of mobile data. Again, buy refurbished or repair whenever possible. Now, Amazon was using it in their data centers. The same philosophy you also can apply in your daily life. Use your devices with care, maintain them well, increase the longevity of the devices so that you don't add to that e-waste problem unnecessarily, right? The next category is reduced storage demand. Delete the unnecessary emails. Yes, space is not a problem these days. You get 50 gigs, 256 gigs, 512 gigs of cloud space on your phones. Space does not seem to be a problem, but then it actually is a problem if you are not using it cautiously. So please take that 1 minute of extra pain to delete that unnecessary WhatsApp video or that attachment that you do not need. You do not even intend to open it for the rest of your life. Right? So just delete those emails, unsubscribe from newsletters which you are not reading because they're eating up space in the Google data centers if you are a Gmail user, right? If you are storing some photographs if you're archiving photographs, do zip them, right? Because if you zip them, it would consume less amount of space. Eventually, your demand for space gets reduced, lesser hardware needs to be made, and then eventually lesser hardware gets added to that e-waste. Adopt eco-friendly digital habits. Reduce the social media scrolling, the endless scrolling, right? So the amount of time your phone is turned on, the display is on, it's more and more heat that you are generating. So that will, give you a healthy lifestyle also. I mean, for your eyes also, it's not good. At the same time, for sustainability also, it's a great boon. Save bookmarks instead of searching every time. So these are small eco-friendly habits, right? So whenever you need something, Google seems so easy to use. So I can get it on Google. You search it. But remember, every time that you are searching in, there is some computer running in the back end, running that search operation, fetching the data from the server, getting it all the way across from the Google data centers to your laptop. It's energy written all over it, right? Instead, if you have found one important article or an important website which you think is something worth saving, or if you think that is something which you would need in future, just manage your bookmarks well, categorize them, save it so that the next time it's already available on your laptop and you don't have to do that traveling across that network, right? And the most important thing, I believe personally, is talk about sustainability continuously to raise awareness, right? So which means, I mean, often we say talking will not give you the results. You need to do something to get that result. But then if we don't talk, if more and more people are not made aware of this whole problem or this whole concept of sustainability, be it IT, be it your daily life, anywhere across any industry, so people will not even think of acting on it. So talking will help in this case, definitely. So talk in as much forums as you can, in as much conversations as you can, bring in this topic so that more and more people are constantly made aware of it. Last but not the least, what can the academic brain power do to help, right? So it's research, right? So it's research at the end of the day. So the academicians, they can think about newer kind of materials which are energy efficient. They can think about how to solve complex problems through AI, right? So they can behind every engineering there is a discovery or an innovation or an invention, right? So that is what is expected from this academic brain power, is to constantly keep on challenging and constantly keep on thinking about the newer ways of doing things, right? So that's something which is expected, and all of the academicians are doing also, I would say. So this small animation I would like to play, and I would close my talks with that. So it tells us about the 17 sustainable development goals that has been adopted by UN, and that has been given to every country. I mean, every country part of the UN has been asked to adopt these goals. So these are 17 heads under which the UN says the drive for sustainability can be clubbed. So let's have a look at it. Yes, I would like to close my talks. I would stop sharing my screen. I hope I was able to impart some of my thoughts across to you. It's up to
Thank
you,
you,
Dr.
sir. Thank you for the excellent session. I think at the moment the chat window is actually filled up with all the compliments. And I'm very sure that this insightful session has enlightened the participants about the real scenario, and I would say the importance of having sustainable IT at this point of time. But yes, we have a lot of questions before we part our ways for the day. So I will now like to take up the questions with your permission. So first question I have, do corporates compute, measure and improve upon building green software? How much of change have we seen in the last 1 or 2 years?
Yeah, so like I told, right? So the opportunity which I showed in that NASCOM slide, so that obviously is an eye opener, right? So there is definitely for the IT industries to make themselves, skilled with sustainability solution looks to be very lucrative also. And if not for the environment, at least for the fact that more and more companies would want to have sustainable solutions, that means we, the IT service providers, we also have to be ready to generate those kind of solutions. So yes, there are initiatives within every major IT organization. There are subunits or practices that are working on having such models in place. So there is a dedicated practice almost in every leading IT service provider.
Thank you, sir. Next question I have. How supportive are the regulations in terms of green IT technology, especially in a country like India?
Yeah, so India has to catch up. If to the extent I have read, India definitely needs to catch up. Like I gave the example of Europe. In Europe, they are making it mandatory. I know one example, one of my previous clients. So that was from an insurance that domain, right? So insurance industries, insurance companies, they need to invest their invest their money so that they can come up, so that they can grow their corpus, right? So there is a clear directive wherein a certain percentage of their money can be put into funds, only those funds which have a ESG rating or a sustainability rating beyond a certain point. So those, yeah. So, and in case if you are not, then you are asked for explanation. So those kind of stringent measures will have to be brought in place. Europe is a pioneer in that case. I would say USA is catching up. But then, yeah, in India and Asia, I think the rules are probably still lenient. We need to be more stringent about it. Yes.
Absolutely, very rightly said, sir. Another question I have, what are the trade-offs between performance and energy efficiency in terms of green IT?
That's a very, very good question, I would say. And probably I would have also liked to touch upon it. See, all the design principles and the coding principles which I shared, right? If you look at it deeply, these are not new. These are not something which has been newly discovered just to address sustainability problems. These principles were also used to make highly scalable and high performing solutions also. You talk about microservices, you talk about auto scaling. All these concepts give us performance also, and at the same time also meet the sustainable requirements. So it's not that we need to do a trade-off between performance. If we can get the right balance, we can get adequately high performing applications even by meeting the sustainability standards, right? And in a way, if you go serverless, etc., you get to reduce your cloud expenditure also. So it's a win-win in either way.
Yes, sir. One last question, which I would say is again very important. With more and more LLMs coming and huge data center and significant power needs, how does one bring in more sustainability on the IT side? And this, I would say, especially for the medium players or the small scale industries. Because for giants, yes, switching over to sustainable practices would be much easier. But what about medium scale or smaller enterprises?
Yeah, so there are lot many models available right now, right? So you need to first understand what is the problem statement that you want to solve. Okay, so like the example that I gave, right? So if you have a pharma problem to solve, right, just do a recce and check what are the lightweight LLMs available, which is predominantly specific to the pharma domain, right? So you need not get an LLM which kind of has a great width which covers different industries. You don't need to know about the aviation industry. You don't need to have the knowledge of aviation in your LLM. So if you can find the pharma LLM, or for that matter, you can train a model with just your kind of data set, you end up building a small model which is economical in terms of building as well as sustainable in terms of running it on any server, right?
Absolutely, very rightly said, sir. And with this, we come to an end to this wonderful session today. But not before I would say we'll thank you with a small e-memento and a certificate as a small token of appreciation and remembrance for this wonderful session today. So Huda sir would have loved to present it to you, but as sir said, he is busy with our Talkatora event of Bharati Vidyapeeth Pune. So, sir, please accept this e-memento from BVI CAM as a wonderful remembrance for this particular session today. Thank you so much, sir.
Thank you very much. The pleasure is all mine. Thank you. Thank you very much.
And so we also have a small certificate. Once again, thank you so much, sir. Thank you so much for this wonderful presentation. The simplicity with which you have explained this concept of sustainable IT today, it's actually appreciable. Thank you so much.
It is sustainable.
Yes, sir.
It is more
Thank you,
sustainable.
Swarajata. Nice one.
Sajay, thanks.